Welcome to another lesson. We're going to be learning about solving equations with a single unknown. Now, if you are in grade 6, 7, or 8, and even if you are in grade 11 or 12, we are going to be learning about this current concept or using it during that period of time. Now, let's get right to the lesson to help you understand it and clarify what we need to be learning about. Now, when it comes to solving equations with a single unknown, the first thing that we need to keep in mind is how do we initiate the steps. So this is the title of the lesson. Let's say I do have x plus 6 equals to 10. Now, what I would like to do is try to keep x by itself. This is the main target when you are trying to solve equations for a single unknown. You want to isolate the unknown. And how do we do so? By removing everything which is connected to it and putting it on the other side. So how can I get rid of the 6? I'm going to say minus 6. I'm going to say minus 6. Now, why did I deduct 6 from both sides? Because it's an equation. Whatever you do on the left side should be done on the right side in order to make sure it balances out. That's why it's called an equation. So by doing so, I'm going to have x equals to 4. How can I check if my answer is correct? I'm going to take the 4 and put it back into the equation. So I'm going to end up with 4 plus 6 equals to 10. So 10 equals to 10, which is perfectly correct. Whatever was on the left side equals to whatever was on the right side. This is the basis of an equation. Now, whenever you have addition, you are going to try to keep x by itself by subtracting from both sides. Let's have another example. Let's say I do have x plus 10 equals to 11. What am I going to do in this case? I'm going to isolate x. I'm going to say minus 10 and minus 10. Then x equals to 1. Put it back into the equation. I do have 1 plus 10 equals to 11. So I have 11 equals to 11, which is perfectly correct. And the same applies when you are doing the subtraction. Let's say I have x minus 4 equals to 12. How can I get rid of the minus? I'm going to do the opposite. I'm going to add. So I'm going to say plus 4, cancel each other out. X equals to 16. Take the 16, put it back into the equation. I'll end up having 16 minus 4 equals to 12. So 12 equals to 12. Again, my answer is correct. So when you are doing addition on subtraction, you have to just simply do the opposite in order to get rid of the number. If you have a plus, subtract it from both sides. If you have minus, add the number on both sides and try to keep x by itself. Now, let's take a look at the case of the multiplication. Now, most probably you should notice at this current point that whenever you have something in the equation, in order to get rid of it, we need to do the opposite. And the same applies for multiplication. Let's say I have 3x equals to 9. I need to isolate or split the x away from the 3. How can I do so? By simply dividing by 3 from both sides. That way, 3 is gone with the other 3, and I end up having x equals to 9 over 3, which equals to 3. How can I check this? Again, take the 3, put it back into the equation. 3 multiplied by 3 equals to 9, then 9 equals to 9. You end up having both parts of the equation to be correct. Now let's apply this for the division. If I have x over 3 equals to 9, or x divided by 3 equals to 9. Both of them, they mean the same thing. The one on the left side is basically in the form of a fraction. The one on the right side just simply by having the divided sign. So x divided by 3 equals to 9. I need to find x. What you need to do is multiply both sides. So multiply this side by 3 and this side by 3. When you multiply 3 on the left side, they're going to cancel out with the 1 at the bottom because 3 over 3 is 1. So once you have a division, you have a number at the denominator, at the bottom of x, multiplying it by the same number is going to cancel them out. So we'll end up having x equals to 27. How do I check? Plug it back into the equation. I'm going to have 27 over 3 equals to 9, and I have 9 equals to 9, which is correct. And the same applies for this current part as well. X divided by 3 equals to 9, the same application. You multiply both sides by 3, you end up having x equals to 27. Now, let's go through a couple of practice examples. We're going to solve them together. Now, make sure that when we are going through the example, that you pause, try to do it on a piece of paper, and check if your answer is correct. So we have the following example. 6 plus x equals to 12. This is example number 1. Example number 2, we have x minus 5 equals to 10. And example number 3, we have 8x equals to 16. And example number 4, we have 8 over x equals to 16. Let's make things a bit more interesting. So let's solve the first one. I'm going to keep x by itself, like we have mentioned. Since we have addition, I'm going to subtract 6 from both sides. I end up having x equals to 12. How do I check? Actually, x equals to 6. 12 minus 6, x equals to 6. How do I check? Put the 6 back into the equation. I'll end up having 6 plus 6 equals to 12. Let's jump into example number 2. How can I get rid of the minus 5? By doing the opposite, by adding 5. So plus 5 and plus 5, x equals to 15. How can I check? Put it back into the equation. 15 minus 5 gives you 10. So both of these answers, they are correct. Now let's go to example number 3. I have 8x equals to 16. How can I get rid of the 8? Because it's being multiplied, what I'm going to do here, I'm going to divide. So I'm going to say, divide by 8, remove the 8 at the top and the 8 at the bottom, so we have x equals to 2. How do I check? Put it back into the equation. 8 multiplied by 2 equals to 16, so I have 16 equals to 16. This one is correct as well. Now, like I've mentioned, make sure that you pause the video at multiple points as we go through the examples in order to help you practice and try to apply these things by yourself. And for the final case, what we are going to be doing is we are going to have 8 over x equals to 16. But you notice here, things are quite different. We have x at the bottom. So how can I do so? Well, we're going to be solving it with 2 steps. Now, the same thing that we have learned so far, we are going to try to keep x by itself. How can I do so since x is at the bottom? So what I'm going to do is I'm going to multiply x by both sides. X and x. I'm putting the dot product here like a point just simply to show that's going to be multiplied instead of putting x multiplied by x, which might be confusing to some of the students. So in this case, x is going to be cancelled with x. Then I end up having 8 equals to 16x. So I was able to shift the x to the other side. Now I'm going to do the second step, which is divide by 16. Divide by 16. X equals to 1 over 2. X equals to 1 over 2. So how have I done it? Simply, what I've said is, since I have x to be at the bottom, I need to move it somewhere where I can just simply control it better. So I'm going to do, what I'm going to do is I'm going to multiply x on the left side by x and x on the right side. Because whatever I do on the left, I'm going to be doing on the right. That being done, I was able to eliminate x from the left side and just simply have it on the right side. The equation works perfectly. Nothing is wrong at this point in time. Now, what we're going to be doing is we're going to simplify the equation where I have 8 equals to 16 of x. we're not done yet. We need to get the number x. So I'm going to divide by 16 because I have multiplication now. I'm going to do division. I'm going to divide by 16, and 8 divided by 16, I end up having x equals to 1 over 2. Now, make sure that you apply these problems, yet you go through them one more time. And if you do have any questions, feel free to write them down in the comments. Like I've mentioned, try to attempt them by yourself, share your answers in the comments, and everything should be perfect, working perfectly fine. Let's recap the steps. We've said that at the beginning of the current lesson, we're trying to solve equations with a single unknown, where we have addition, subtraction, multiplication, and division. The main target is to keep x by itself on one side of the equation. So if we have addition, we're going to subtract. If we have subtraction, we're going to add. If we're doing multiplication, we're going to divide. And if we're dividing, we're going to multiply. So the main point is, in order to keep x by itself, you have to do whatever it takes in order to keep it by itself. So if you're adding, you're subtracting. If you're multiplying, you're dividing. And the key point to keep in mind is, you're going to do so for both sides of the equation in order to make sure that you get the correct answer. Now, that being said, I truly hope the lesson was beneficial to you, and I'll see you in the upcoming lesson.